class.
Oh, same. No, straight up. I like failed that class, but I was sobbing on the phone with my friend. Like, please, like,
I would say yes,
can't
but
not
not
have this class.
Even in the executive courses, so I got this providing comments at the end. It's so funny that that's what
Okay, welcome to our weather discussion for today. We're going to start with an update on the cold pool at 850 millibars. Pete, if we could do that.
Update on the which?
It's the cold pool. I have the image in the back. Yeah, so that looks scary to you? The last 3 days before today, I guess we tied the all-time minimum. The last 3 days were all-time minimums for the hemispheric cold pool at this time of year. This time series, up till that point, look at, we only had 2 days, 2 or 3, 4 days at the beginning of the month where it was a little bit above the average. And we have been below the average all the way through. This got me a little scared. I thought, wow, that's probably unusual. Turns out it's the third warmest period, September 1 to October 19th, in the 76-year NSEP time series. And it's barely out of second place. So it's almost the second warmest. And the other two were, I think I wrote them down, 2011 and 2012. How interesting. In 2012, if we can go back, Pete, to the NC National Storm and Ice Data Center page that I got up there, there's one right here. 2012 was the all-time lowest Arctic sea ice extent on right around September 19th, 20th. As soon as the sun goes down, the ice starts growing again. You can see even in the long average, it goes up almost more rapidly than it goes down. But this blue line here is 2023, and it's the fifth lowest sea ice extent at the end of the melt season that we've ever had. The other ones that beat it are 2020 and 2019, back-to-back, 16 and 27. So we've had all these years, in the last 16 years, 5 of them have been the all-time minimums. And so this is all not good, and it's all related. If it stays warm over the hemisphere after the sun goes down at the North Pole, which it has, we're at effectively the second warmest ever from September 1 to October 20th. This is not really a good thing. And this is not just in 1 or 2 regions. I looked at the, I can't show you the map because it doesn't project so well here, but you can see the animation from day to day. All over the northern hemisphere, places are way above normal in terms of where the -5 isotherm actually is and where it usually is. And so we're way in deep trouble here. This is a really odd beginning to the spring, to the fall, and we're seeing it manifest in yet another signal. So I wanted to start off with that. I don't want you to go home and rip your hair out or anything, but you know, something's going on here, and it's a little bit nerve-wracking. Okay, thanks, Pete. Let's now go back to our regular scheduled programming, which will be, let's take a look at our, I think I brought the, right there. Yeah, here's the infrared satellite movie for the last 6 or so hours. It's a fairly complicated scenario across North America today. In fact, most of what I'll talk about, and I'll peek a little bit into the forecast, only because looking at some of these features that are currently arrayed on the chessboard requires seeing how they evolve. But we'll take a look at all of this complex, interesting weather on the eastern part of North America. We had a couple of different disturbances traipse through here the last couple of days. One of them brought us a little bit of a threat of rain. Didn't really rain. It was the second one that really rained on us last night and into the evening. But and the clouds associated with the first disturbance, weak as it is, and we'll see that in just a minute, are fairly low compared to these higher clouds off the coast. And we'll see in a look at a couple of different data sets that here's Hurricane Norma spiraling away south of the Baja Peninsula. And yesterday was particularly evident, extraordinary rapidity for the clouds, high clouds that were moving across the Gulf of Mexico. And there was a really strong subtropical jet. That jet has turned poleward and is associated, I think, with some of the cloud development off the coast. Meanwhile, an extratropical disturbance of clear extratropical origin is getting itself organized again over the Great Lakes states, and it's going to be a pretty interesting weekend off the coast of New England. I think they'll get down to something in the mid-low 80s, 980 millibar pressure range, and fairly heavy rain. So a pretty decent blustery October weekend for New England. We'll talk a little bit about the ingredients that go into that. Look at the rest of the United States, though. Extraordinary clear across, what is it, 3/5 or more of the United States. A little bit of clouds in the Oregon, California coast, and some in northern Washington. But other than that, it's almost perfectly crystal clear across that giant expanse of land here in North America. So pretty interesting. And Norma, I didn't check anything about Norma. I don't see an eye today. It was a little more obvious yesterday, so perhaps that's an indication that it's weakened. Does anybody know anything about Norma? Current stat? It is weakening, so it was category 3 yesterday afternoon. I think it must be at least less than that now. But it hasn't moved much, and that's not good for hurricanes. They shouldn't sit still because they churn up the cold water and suddenly, you know, the fuel is gone. And so the progression's better than stasis for hurricanes. But that doesn't seem to be the case with Norma. Okay, so that's the broad picture aloft. Let's take a look, Pete, if we could, at the radar across the continental U.S. before we start thinking about diagnosing any of this stuff. So here we are. See how scattered all this precipitation is? It was even scattered when it came through us last night. And then the night before, though, remember there was that really nice line and a really kind of nice comma-shaped cloudiness and precipitation feature, but it just kind of died out before it got into Dane County. Just it made it across the border, I guess, but not really substantially into Dane County. And then the second disturbance had a little bit more circulation oomph to it, but it doesn't have a well-organized precipitation shield, partly because, as we'll see, it doesn't have a very well-organized baroclinic structure, and that doesn't help if you're trying to put precipitation bands together. So that's part of what's going on here with this disorganization, although it's widespread disorganization, and rather like the Republican caucus in the Congress. And then here's the precipitation that's also scattered along with the subtropical jet, okay, that you can see. And then the only little bit of precipitation associated with Norma is the far northeastern extremity of that disturbance. Well, that's not Norma, actually. This is something else that's affecting Santa Barbara and the Bight of California, but not in any substantial way. So that's about it across the continental U.S. What will happen in the future is this thing's going to get a little bit better organized. It's going to develop off the East Coast and churn up toward New England. And I want to tell you a little bit about some of the ingredients that will cause that to occur. But before we do, let's go to the West Coast satellite image if we could, Pete. Yeah, so here's what's going on off the coast. So there's Norma, the western periphery of Norma. ITCZ is fairly well lit up around almost all the longitudes, a little band of gap right in here. It looks like a first grader's teeth in a way. And then, and then here's a little bit of a baroclinic leaf cloud, but not really a developing disturbance. This one's a little bit better organized south of the Aleutian Islands. But even this, by Pacific Ocean standards in mid to late October, is really boring. This should not be what the Eastern Pacific looks like. It does today. The far Western Pacific is a whole other story, though, and we'll say a little bit about that as well. Boy, if you were on the western shore of the Sea of Okhotsk, Far East Russia this weekend, and you like snow, you'd be really happy. And I'll show you a little bit about that. So that's me I'm talking about, but I'm glad I'm not going to be in Eastern Russia this weekend. Though I'm content to wait for the snow to come here if it ever does. Okay, so so that's the broad picture there. It's storm less across the Pacific right now, but that won't stay the case for very long. It never does. Let's take a look now at some of our upper level charts, Pete. We'll go to this Super Pete at 500 millibars to begin. So here we are this morning, 7 a.m. Deep trough, negatively tilted, as you can see, across the eastern United States. And on the western side of it, really intense winds at 500 millibars. This is 85 knots near Dubuque, and about 85 a little further south near Lincoln. And so pretty intense upper level jet. The baroclinicity is decent. I wouldn't say it's record breaking. We're minus 22 at Green Bay, minus 22 at Cincinnati. So this is the cold pocket. And then the warm air is like minus 10-ish from a line from like Little Rock all the way to Lincoln, to Omaha. And so that's 12-ish degrees. We'll see much better than that deep into the winter. But it's enough to get something interesting going, as we'll see in just a minute. So this upper trough, you can see the asymmetry in the wind speeds, even if you didn't see the ice attack, the wind bobs, just the geopotential height gradient's weaker on the eastern side than it is on the western side. That often means that this kind of feature will deepen. And the reason why, I think, is because when you have a jet streak here and it has its own exit and entrance regions, they have characteristic circulations. The exit region is characteristically thermally indirect, and though that will be worked against a little bit by the ageosphere of trough. So there's ascent over southern Indiana, maybe southern Illinois, where it's already cold. So you're going to make that air colder and the thicknesses will go down, and that means the heights go down in that location. So this troughiness develops usually when there's a jet on the western side that's stronger than the one on the eastern side. And that seems to be the case today. And then, portent of things to come, two things to come. First, stronger baroclinicity, a little more concentrated baroclinicity across the southern western provinces of Canada, and the occasional invasion of a little bit of a wave induces some cold advection in cyclonic shear. We were talking about this yesterday with the Sorey-Leeson explanation. That helps to produce subsidence right under the jet core and begin to develop an upper front, and more troughiness, more vorticity. This is the second time this week a little disturbance northwest of Lake Winnipeg in Manitoba has reared its head and kind of been in a position to further deepen a trough that's a little bit downstream. This was like what happened with our second disturbance, the rain-producing one from last night. But then another portent of things to come, you don't get it much colder than about -40 or -45 at 500 millibars anytime during the year. And look at that, right on the Yukon-Alaska border, we're already there. That is really, really cold air. Okay. So it's being manufactured, apparently, and it is ready for export. And it's only October 20th. So check your closets this weekend. Make sure you have what you need, because you never know when it's actually going to be let loose. And there's, as I think Lyle Horn, the late Lyle Horn, was a member of our department before I came here, said, there's nothing between northern Canada and the central United States except grass and a few barbed wire fences. And so keep that in mind. That's a good thing to keep in mind. Okay, so that's the 500 millibar discussion for now. Let's go to 300 feet, just to reemphasize a couple of those features. Yeah, look at this jet. We'll see more evidence of this when I bring you to Vis 5B. First of all, asymmetric. Extraordinarily strong on the western side, almost non-existent at 300 millibars on this side. Go to 200, it's going to be different. This is 135 knots right here in Lincoln, Illinois. And same thing at Dubuque. So that's the core of the jet, 135 knots. It's not a stubby exit region. It's a pretty intense gradient of wind speed, and so one can expect development of this upper trough with some reasonable assurity. The jet is anticyclonically curved, which will alter some of the circulations around it. That is of interest to me, but we haven't really, Dan Kaiser and I have been talking about that for years, kind of looking at some of these things in idealized models. We haven't done it yet. Here's a little trough that's going to find itself right on the crest of the jet, and that will also serve to further dig this and deepen this whole feature. And then here's where the cold air was at 500 millibars, and there's a very intense polar jet, little stubby one on the southern end, southern periphery, I should say, of that cold air. And finally, Pete, let's go to 200, and I think we'll see that jet over North America recedes in intensity, and this one kind of grows in intensity, indicative of the fact that this is more of a subtropical feature, this is more of an extratropical feature. And there's nothing left of the one on the southern end of the cold pool, because it's just, you're already deep into the lower stratosphere by the time you get to 200 millibars in that kind of a column. Okay, so that's the broad setup over North America at the present time. Okay. What do I want to do next? I think what we'll do next is, well, let's see what I did want to make this point too. Let's go to 850 millibars, because one of the things that's characterizing this whole development region in the eastern United States is lack of baroclinicity. I know that came up in my discussion a few minutes ago, and I forget now the context, but look over the eastern United States. Here's the lowest geopotential height, a little bit of a trough over central southern Illinois, maybe. You can pick that out by eye, and that's the feature that's going to be the one that deepens the trough more. But there's almost no temperature contrast, all the way from, Jacksonville's 11, Caribou's 4. There's only 7 degrees along the entire Atlantic coast, and there's nothing laterally either. So this is a broad region of no baroclinicity. And that, isn't particularly good for the development of cyclones. It takes low-level baroclinicity as one of the ingredients to really drive intense development. We don't have it over on the eastern United States. Now, except for the fact that the ocean water is really warm. But in the lower troposphere, there's not much baroclinicity. And then on the western side of this upper trough, even at 850, that's where the baroclinicity is. You go from 6 degrees at Dubuque to 19 at Dodge City. So that's a strong horizontal temperature contrast, and you can see it lasts all the way from Lake Winnipeg down to about southern Arkansas, northern Mississippi. That's a pretty intense 850 millibar baroclinic zone. Not much advection of the temperature, though, with it, because the flow is almost exactly parallel to the isotopes. So there's not much moving around of the temperature around North America, especially eastern North America. Not much temperature advection. Even where one might suspect it's really cold, you limit your cold advection to the upper, Great Slave Lake, up in the Yukon Territory, far northern Canada. It's not really making it into the prairie provinces. So a lot of the action's off-site in a way, but not all of it, and that's what makes this fun. So if we could, Pete, let's go to Viz 5D, which I think is in the background. I don't think I forgot anything else. So here I'm showing you not last night's, Thursday nights. No, it is last night's. Last night's GFS forecast. I've made the sea level isobars every 2 millibars because we have a really weak disturbance over Lake Michigan, 1,004. I just want you to see where it is. And almost nothing going on along the East Coast. And this is last night at 0Z. Let's put the speed on top of here, just so we can be, and this is at about 9 kilometers, so 300 millibars, just to be reminded of where that intense anticyclonically curved jet was. So this is, higher than the surface, but it's at 9 kilometers. But it's a really intense jet, and it has lots of interesting features associated with it. The cyclonic shear on the northern side is intense. The anticyclonic shear is a lot weaker. It has to be because it's also got anticyclonic curvature, so you can't have negative absolute vorticity. It'll just wash itself out. And so you have a really strong asymmetry in the gradient of the wind speeds. But notice where the cyclone is. It's just about in the left exit region of this jet streak as it's kind of poised to head southward across towards the Gulf of Mexico. That's a perfect place for a weak storm to kind of reside, and it won't maybe get any more intense, but it's not going to get any weaker because there is a little bit of divergence going on in the right spot aloft. Okay, so that's interesting. Let's take the speed off, Pete. And then let's put the PV. This is the 2 PVU surface colored by pressure again, like I've done before. And you can see that the jet is just about where you saw this kind of ridginess in the PV. In fact, let's take the sea level pressure off for the time being and then tilt this up so you can see what the topography of this looks like. This is colored by pressure. And so, yeah, go ahead and spin it around, Pete, so you can see. So keep going. Yeah, so here's where the ridginess is in the PV surface. Maybe I can take the map off for the time being. I put it up high so we can keep on seeing it. And then dip down a little bit. So the jet is right where this surface is really steep, and that surface is kind of ridgy in its shape, and so the jet is going to be anticyclonically curved as it rings the northern periphery of this low PV in the upper troposphere, but high elevation 2 PVU surface. And then there's the trench, which is characteristic of the jet itself. It's usually right in that trench. So let's go back to the top view. Okay, and then before we do anything else, a couple of spots where you get a little more orange. Those are just local depressions of the high PV air. And so you can think of them as depressions of the tropopause. And they're not uniform, but they are in a line. And so one gets the sense that there's something kind of systematic happening at the base of this trench. And we want to see if that evolves. So remember, this is 0Z last night. So let's click ahead a couple of times and watch what happens. So now we're getting to about 12Z this morning right now. And we don't have to have the map on for the time being. And you can see this gradient in color, and therefore gradient topography of this surface gets a little more intense as we go this far into the future. Let's go one more time. I think I had it at 12Z. And then I think I have cross sections here. So let's try theta. Let's see where it lines up. Maybe I go to 18Z. Let's go a couple more times. Or 0Z on a couple more than that. 0Z Saturday, that's where it was. So by the time we get to 0Z Saturday, look at how close the deep orange is to the dark blue. It's the only place where that's true. So this is the steepest part of the tropopause. In fact, before we look at the cross section, click it off, and let's just tilt this up and just see what's going on underneath this thing. So that's a pretty intense downward protrusion of the tropopause. And it slopes. It's not all the same depth. It's less deep to the northwest, and then this is about the pinnacle of its depth right here. So let's go to the top view again to remind ourselves where the cross section is and put that back on the theta cross section. That's horizontal. And then we're going to also, let's do one at a time. So we'll flip this up and take the PV off. Yeah, take that off. And this is every 3 degrees Kelvin. And there's no surface front to speak of. This is a strong upper front. Let's put the cross section of PV on that. And so there's the downward protrusion of the PV. It goes all the way down to just about 500 millibars, and I'll show you that in just a minute. And that's a fairly steep wall of tropopause wall. Here's the tropical tropopause. Here's the extratropical tropopause, and there's nothing in between. And that's really intense. sort of a tropopause wall. I also put omega on here. I'm looking just at downward vertical motions. Let's get rid of theta, I guess, for the time being, make it a little more clear. These are all downward vertical motions. So there's a lot of downward vertical motion right here along this wall. Let's put theta back on there now that you've seen that. And that's going to subduct some of this PV right along these sloping isotropes. So I suspect it continues to deepen. The protrusion does a little bit. And what else did I put on here? Did I put speed? Let's try the speed. I did. Let's get rid of the PV. So there's the jet core. This is 30 every 5, 35, 40, 45, 50, 55, 60 meter per second. And if you put omega on there again, this will sound like what we talked about in 452. Oh yeah, substance right through the jet core. So there's something interesting going on, and this is an upper frontogenetic situation. And they always catch my attention. This thing, of course, if we go back to the surface, the top view, I should say, put the colored PV on top, and then the sea level pressure. This is all happening without any attention being drawn to it at the ground. Look what the pressures are at the surface, 1,006, 1,008, 1,004. That's nothing. It's barely below standard sea level pressure. So the action at sea level is not in the vicinity of this developing upper front. This is the old cyclone, the one that's over us now, and there's a little bit of something beginning to develop here, but it's nothing to write home about. We put the map on top, Pete, we can see where we are. That's right off the coast of the Carolinas, middle Atlantic states, right? So there's nothing really interesting going on at precisely this time, except in the upper troposphere, where there's a strong upper front being developed, and all of the ingredients, the guns being loaded, the springs being wound for the downstream development. So let's take the PV off. And cross-sections can come off too, I think, yeah. Let's put PV at 500 millibars. So that whole protrusion barely touches the 500 millibar surface. This is the one PVU contour that's right at 500 millibars on the Tennessee-North Carolina border tonight at 7 p.m. And let's click a few times ahead here. Watch what happens to that. It's going to round the base of the trough. You imagine that's what's happening. Then it gets one more time, two more times, right here. Gets positioned right in this location. Look what's happening to the sea level pressure, 994. Let's put theta on top of this, which is a proxy for the thermal wind, because it's theta at about 3.5 kilometers instead of 5.5, which is where the PV is. And so here's a bundle of isotropes every 3 degrees Kelvin, and that's a pretty strong gradient, so the thermal wind is like this. If you imagine this PV as a proxy for the 500 millibar vorticity, which I'll show you it is in just a minute, then you can see pretty intense positive vorticity advection by the thermal wind going on right in the vicinity of the developing cyclone. Let's take, I didn't do this yet, but we can do it on the fly. Let's do QZ at 5.3 kilometers. Perfect, that's good. And then let's make the contour interval 4 parentheses, starting at 12 up to 5,000. We'll never get that high. Okay, and then let's change the color of that. Let's make it yellow. So red and green, no blue. And then take don't take the theta off. Take the sea level pressure off for the time being, and take the PV off. Thank you. So here's what that 500 millibar PV feature looks like in terms of vorticity at 500 millibars at the same level. So it's pretty intense, and you can see there's pretty good positive advection by the thermal wind to about this location. Can you remind me where the sea level pressure minimum is, Pete? Oh, well, that's perfect. So that's what's going on right there. So here we have, this is what's going on in the next 12 hours. This upper front in the northwesterly flow over the western part of the Carolinas, actually maybe over the Ohio River Valley, is pushing the tropopause down by the subsidence under the jet core. Probably because of cold advection in cyclonic shear. We can assess that, but we don't have time. I want to give Patrick time. That's being forced down. As it goes further and further down, it intersects isobaric surfaces, like the 500 millibar surface, the one we commonly look at the vorticity on. And so put the PV back on again, Pete. The contour, yeah. Right where the PV reaches the 500 millibar surface in blue, you can take it off again, is where the vorticity is maximized at 500 millibars. That's not an accident. That's, of course, a conspiracy. They're the same thing. And if you put that in the right spot with respect to what the thermal contrast looks like at the base of the trough, you can produce PVA by the thermal wind. Things start to get interesting in Long Island Sound and across coastal New England as you move forward from this time, because this upper vortex is part of the development scheme that drives this new storm. And this is the sort of appendage that's left of the one that went past us last night. The main storm is this one right now. So that's kind of a cool way of looking at it. One last thing I want to show you is trajectories. I only have one set, and it's set 4. And let's go back to 0Z on Saturday, so we gotta go back sometimes. Okay, and let's put the cross-section back on of theta and the PV. Thank you, and then we'll tip it up. Just to remind you, this is what we're looking at, is this air parcel right here. So right at the forward edge of this PV wall on one of the sloping isotropes. And if we kind of take everything else off cross-section wise, you can kind of see, and then rotate this so you can kind of see the orientation of that. That parcel of air, it's subsiding in the last portion of its trajectory, but it was mostly crossing along horizontally, a little bit of subsidence, and then more rapid subsidence as it starts to develop the upper front. Let's put on the top view, let's put the jet, the speed isotax on there, and sure enough, we click back to the beginning and then just go forward to this time, to 0Z. Look at how that air parcel, this collection of air parcels indicated by that trajectory, are riding the cyclonic shear side of the jet, and then they come into the jet core, and that's when they begin to subside. And that's where we were right there, I think, the time prior to this. And that's where we're developing the upper front. So all the stuff we were talking about in class is vividly illustrated in a weak case right here. So imagine in a strong one, how strong those signals are. It'll be really dramatic. Okay, that's all I have. Patrick? Perfect. Thanks.
Thank you.
Thank you, Pete, for expert driving again.
Can we start at tropical tidbits, please, Pete? I want to go backwards in time, looking at Hurricane Norma specifically, because it's actually, I looked at it and thought, this is a pretty normal development, it's a hurricane, whatever. But its development was actually pretty interesting. So if we could go to regions, and we'll do Eastern Pacific, and then we'll change this runtime to be 0 UTC October 7th. 17th, yes, sorry. And then could we go to lower dynamics, the 850 height and wind, and we'll go backwards in time to, I think, the 15th at 12Z. Should get us to where I want. Okay, so if you remember, earlier in the week we had a cold front, and it's indicated by these northerly winds all throughout the southeastern United States. Interestingly enough, there is a mountain range, the Tehuantepec Mountains here in Mexico, that funnels wind as strong cold fronts that make it all the way down into the Gulf of Mexico. In this case, all the way down to Mexico. Funnels the wind. You can see the contours of wind in the color fill increase as it goes through this mountain range. It's kind of like the geology in the AOS building, how you walk through and it's really windy and it's amplified. And what happens then is, if you remember back to Dynamics 1, we talk about the regular low, the regular high, anomalous low, anomalous high. This is a region of the world, I think the only one, where you can actually develop what's called the anomalous low, which is a low pressure, right here. You have slight anticyclonic winds, because as you're moving down south, you're deflected by the Coriolis after you get through the mountain range. So you have a slight anticyclonic curvature to the winds and a low pressure. And so this happens regularly when we have strong cold fronts. But let's click forward and see what happens. You kind of already got the punchline, but we could keep clicking forward. We see the winds continue to strengthen. You have this strong northerly flow. And this is GFS analysis all the way. Here's a development right downstream of where we have the strong winds. And if we keep going forward, you can just keep clicking. We'll see, here's Hurricane Norma. Keep going. We'll get to around the current time, so Friday. So that's how Hurricane Norma formed originally. It became tropical. You have strong sea surface temperatures, very warm waters, but originally it was formed just flow through this mountain range. You can still see it's amplified right in this region. This will happen regularly, but this is a pretty interesting case where you have just inconspicuous flow, and then you develop a Category 4 hurricane is what it was at its peak. Like 3 days later after it formed just downstream of the Tehuantepec Mountains here.
Patrick, are you aware of any case studies that document a similar development?
I'm pretty sure there are a lot, actually.
Yeah?
I read a paper in undergrad that highlighted one of these. I don't know if it was a hurricane specifically. This one's pretty intense because you have, I mean, we've had high sea surface temperatures everywhere in the globe, but especially, you know, down in the Gulf of Mexico and then the Pacific. So this might be anomalous, this rapid development and rapid intensification, but it seems like hurricanes now always go through rapid intensification. So maybe this is not as anomalous as it looks, but it is definitely a noteworthy development, I would say. And this will actually move into Mexico, and I'll touch on, the news has been reporting that this Hurricane Norma might, you know, do something to the eastern United States. That's not true, and I'll show you that. Yeah, so I wanted to go back in the past because this was a pretty cool event, and from that paper, I've always been interested to look at the winds around Tehuantepec Mountains and how they can force development. So if we could go to now weather.gov, please. And then I'll go back to our AOS forecast models to end it. And so just looking at the current advisories, watches, and warnings, there's nothing. We largely saw, you know, scattered precipitation, but nothing strong over the eastern United States, and the western 3/5 of the United States completely cloud-free. So this is, I wonder if this might be a record low amount of, you know, advisories, warnings for October, because usually this map lights up in spring and fall, especially in the winter, but largely nothing. And this will change, I'll show, as we go forward into the week. But here's hurricane warnings behind the projection of Hawaii, and then it's kind of funny, you have hurricane warnings and then blizzard warnings. This is for Alaska, so, but it's funny that they're listed right in a row on this map. And then if we could go down to the outlook, the bottom of this page, and I'll just show the quantitative precipitation forecast, as I like to do. And we'll just step through day one. So first we have, here's our weak disturbance over the eastern United States, but decent precipitation all along the eastern seaboard. Of course, it's been really rainy over there, so they don't specifically need all this precipitation, but at least it's not heavy. So it shouldn't cause any major inconvenience to travel or delays or anything like that. Weird little pendant and precipitation band that stretches from Canada maybe impacts us. And this is forecast into tomorrow morning, so potentially you might get a small shower, but largely nothing for our area. If we could go to day two, we see that band has sort of continued to move. This might be just, and I can show this, turns out to be just a small vorticity maximum that was moving up along that jet stream, and it's coming down the trough, and it's forcing some precipitation, and you can see how fast it's moving just by this little pocket of precipitation moving. We can see a development begin to happen over the eastern seaboard, especially the northeastern United States. This, coupled with heavy rain, high winds, you have a lot of trees in this region. It's fall, so this might begin where you have travel delays from trees falling. You still haven't lost too many leaves, I'm sure. If we could go to day three, we can see the middle part of the United States completely devoid of any precip. Eastern or western United States, something begins to form, and this is sort of that storm just beginning to move out over into Canada. We go to day four. Now we're looking at Monday night into Tuesday. We get maybe a small precip chance, but nothing major. The southwestern United States and the southern plains have some precip, and then we'll do day five really quickly. Here's where we start to get, maybe we get some significant precipitation, a band stretching from Texas all the way up into Wisconsin here. And I'll end the QPF with this. So now could we go to our model page. We'll do the GFS model, please, Pete. And I'll take a look at, just briefly touch on what Professor Martin talked about with the development over the eastern United States. And then there's something interesting that happens potentially Thursday into Friday, and I'll end with that. So if we could pull up this surface map, loop and the 500 on 2 separate tabs, please. So I'll flip back and forth between them. Perfect, and we'll start here. We can go to 0Z tonight. So this is 5 or 6 p.m. our time. We can see the trough has largely remained where it has been, but we have a vorticity strip on the western side of this trough axis, and here's where you're going to have strong PVA by the thermal wind. If we go to our surface map, we can verify that, so it should be just downstream of the Carolinas. Thank you. So, let me orient myself. Yeah, so you do have, here's your thermal wind blowing with cold air to its left, and you can see the precipitation forced by it, and a lengthening of these isobars indicative of rising motion. So you're beginning to develop your system right over the Carolinas and eventually off the eastern United States. In our region here, where there is a baroclinic zone, not a lot of flow to really force any sort of advection of these thickness gradients. We have a low pressure, and that's that band we saw of precipitation that might move over the northeastern part of Wisconsin and then into Indiana. And it's just this little inconspicuous low that develops, and if we step forward from this map, 12 hours, we'll just watch that, race down. We can keep going to 0Z actually, and we'll see it just misses us, but we might get some of the precipitation. But it's largely dwarfed by what's going on over the eastern United States. So if we could actually go back to 12 UTC on this map. So we'll see, here's our low sitting just off the coast of the eastern United States. Very strong thermal gradient, especially to the southeast of where the low, or southwest of where the low is located. Very strong thermal wind. You can imagine directed right into where the center of the low is. If we could go to the 500 millibar map, I'll put my pointer right here. Oop, perfect. And that thermal wind was strongest right where the gradient of the vorticity is maximized. So you have significant PVA above the thermal wind right where you had your low, sitting just off of Delaware. And if we go back to the surface, we'll see this low, 987. If we could go 12 hours in the future, we'll see we get down to 977. So this is a significant development, very quick. It's very fast development, but it is significant, and it's over a very populated area with heavy rain, high winds. And at this time, you can notice the baroclinic zone, which was, largely tied to the system, has kind of moved well to the east, and you're losing that strong thermal wind signature. Maybe you have some well away from where the storm is located. And if we could go to the 500 millibar map at 0 UTC on Sunday, we'll see the vorticity kind of becomes messy. You do have a strong gradient where that thermal wind was maximized. You could expect this system to continue to move slightly northeast. I think the map projection might make it seem northeast, but maybe it's easterly. But so you have your development occurring ahead of where the system is, and we'll see that on the surface map. If we just go like a couple clicks in the future, we'll see our storm. It's still 977, but it begins to weaken as it moves off to the northeast. Over our region, this is now Sunday morning, high pressure. We're kind of in the region of we don't have any synoptic level flow because our high is sitting almost right over us. So we don't have anything in the way of temperature advection, but areas to our west are definitely in some fairly significant warm air advection. And I'll just stay on this map. If we could go to 12 UTC, and we'll just keep going on Monday, we'll see here's maybe some precipitation chance that we saw in the QPF. We're still largely in a high pressure regime, but we do have flow from the south, and so we'll warm slightly, and this might be indicative of that southerly flow coming off the Gulf and then forcing some precipitation over our region. We'll keep going here. We can go 12 ETC on Tuesday. And we'll see the beginning of something developing over the mountains. And this will become the interesting thing I want to end on. Here's another precipitation chance, not anything significant. Maybe there's some low pressure, something located to our southwest, but largely discombobulated. If we keep going, we'll go to Wednesday. We can see here's a significant baroclinic zone indicated by the type gradient of the thicknesses moving to the southeast from Canada. We can notice there's strong, heavy precipitation, very strong gradient in the isobars. So this is a significant development beginning to occur. So we'll keep going to Thursday now. We'll watch this system slowly move into the northern plains. And I want to point out, here's your 540 thickness line. And so that can be a proxy for the rain-snow line. And so if you see that cuts through the heavy precipitation, so everywhere on the northwestern side of this, presumably from this look, is snow, and largely heavy snow. This is fairly high values of the accumulated precipitation if this is snow. And then if we keep going to Thursday or Friday at 12Z, we'll see this system move towards the east, and we still have a fairly strong signal for maybe a significant snowstorm from, let's see, this is Nebraska all the way into North Dakota, and then unfortunately, if we keep clicking, we don't get in on any of the snow. We're sort of the warm sector, and this system moves, to the northeast too quickly, but portions of the northern plains might get a significant snowstorm come next weather watch. So that'll be something to look at, but we stay in the rain. But we might, this is now looking at Saturday morning. You can see strong cold air advection over our region. This might be the first taste of winter for us. We've sort of had fall, maybe cold fall, but this might be, a fairly significant cold front that moves through our region, and we get northwesterly winds, low thickness, so we could expect strong cold advection.
Who's our hapless opponent on Saturday the 28th?
Ohio State.
Or should I? Oh,
Yeah,
Ohio
that's
State
right.
is hapless.
At night, so yeah.
Yeah.
Does it go forward any more than this?
Rain,
Or
or
is this
Penn
the
State
last?
gives them their first loss
That's the last
tomorrow.
one.
Yeah.
I am working on a 6-hourly one that goes out to 384. It may or may not be working.
Okay. So that might work to the Badgers' advantage. I mean, they have a strong defense, so can't throw the ball. Ohio State is limited in what they can do, but
So long as Penn
Wishful
State gives
thinking.
them their first loss tomorrow.
yeah, that's right. That's right.
But I'm not counting on it. Penn State has only beaten Ohio State once in the last 11 years. I know, but for some reason we just can't beat Ohio State. The only time we did was in 2016, and that was the batshit insane play known as Block 6. We could have beaten them in 2018 if only Jay Franklin didn't go for the 4th and 5. I hope Michigan gets weakened because of this investigation.
Okay.
Sign stealing. I thought it was a baseball thing.
Maybe 2. Yeah.
Let's see where it is. 12Z on the 28th.
Yes. Okay. So, and then if we could keep going a little bit, we'll go to 0Z. So this is game time.
Oh, I don't know. Florida.
It might
Be a
be some
flurry.
flurries, mixed precipitation.
Flurries.
Can we go one click for us?
Morgan
Snow.
Fantasy.
It's terrible.
So
I like
there
how
might
we
be
do that.
flurries for the night game, Ohio State, when we're celebrating the victory.
Yeah.
But
Look at that anti-cyclone though. There's another Gulf of Tewanapek event coming up
yeah, oh yeah.
in early November.
And this looks like we're into winter now. This is Halloween, so
Yeah.
these are
Cold.
definitely flurries
Yep.
if this is precipitation.
Awesome.
Definitely Morgan Fantasyland.
Yeah.
Yeah, it is Morgan Fantasy, but nonetheless, 1040 over Montana and Wyoming is always exciting for us.
So when there's a heavy snowstorm on November 2nd, you know.
Yep.
It's almost here, but just wait till Thanksgiving to start singing the songs.
Look at the spare clinics out.
Yeah, it's
from this
amazing.
model.
It's taken all year to finally organize it. You know,
Yeah.
we were talking about earlier in the talk about how it's been so warm over the hemisphere. It can't stay that way forever. I mean, there's astronomical factors at play here.
Right.
It's not sunny anymore at the high latitudes. You can't
That's
stay
Something's gotta
warm.
give.
So, yeah.
Something's
All right,
gotta
good.
give.
That's good. Well, that's a really good cold snap.
Wow, that's cold. That is cold.
Yeah.
And then we're back to fall, of course.
Yeah.
Very good.
Taste of winter.
outlook is
Hopefully that won't be our only
Yeah,
taste of
that's
winter
what
this year.
All right,
El Nino is something.
So any comments and questions? What I showed? Okay.
I believe I heard Dr. Martin mention something about how it's interesting to us when there's cold air over the 540 lines over the mountain ranges in Wyoming and Idaho. What would
Yeah, I don't know if I did that today, but one of the things that I keep my eye on around this time of year is it cold enough in Western Canada to start putting snow on the ground? Because if so, that's where, you can tell, look at even in this evolution, that's where cold air gets manufactured in the nearest proximity to us, is over the high latitudes of Western Canada. So if you put a big high pressure system there and you got snow on the ground, you got everything you need, clear skies and radiator blanket, it's perfect. And it looks like that might be one of the factors that's getting itself established. But it's gonna fight against the El Nino, so it's gonna lose. I think it's gonna lose for us. Well, this is like a Morgan plot.
It's just the time zero until the forecast hour accumulation.
Where is that? Is that precipitation?
Yeah.
Yes, it's total accumulation from time zero until the forecast hour, so.
Since Louisiana doesn't get anything, and they need it the most.
They're in an exceptional drought.
I can't believe I'm saying this, but you know what Louisiana might need? A hurricane.
Yeah, it's getting late in the year for that.
Yeah. All right. Well, thank you, Pete.
Yeah, thanks, Pete. Thank you.
Thank you, Pete. Yeah, it seems like,
Glad to get these long ones on there.
a
they're
hurricane might be the only,
ready for prime.
might be the thing Louisiana needs to get
Like, okay,
about
next
a
week.
decade of this
I want
drought
to
there.
have
It's
a
like,
certain too.
it's crazy, I'm even, it's